Yeah, good evening, all. Thank you so much for joining on time. It's yet another free masterclass or a free webinar on ETAP. Today, we are going to talk. I guess like some of you might have seen the single line diagram, but like I'm going to pick up the single line diagram and I'm going to talk about the same single line diagram for the next 60 to 75 minutes. If you're super excited for the session, just put SE, super excited for the session, SE in chat, and we'll get started. If you're super excited, cool. That's the energy which always I love to have. Cool. It's great. And before jumping into the topic, Sally, understand the background of the audience. Like, I mean to say, are you a student or are you working in academics or you are into design engineering or are you into operation maintenance or are you into testing and commissioning or are you into project management? Can you just put up like me to see what's your how you can define yourself so that like I mean to say that gives a clarity for me. All right, Aman from ONM, Balaji from maintenance, Asikali student, Dinesh Kumar student, Kunjan design, Sachin Pandey project engineer, Gulam Ali testing and commissioning, Tejas operation and maintenance, Rion planning design protection engineer, Roshni Patel student, MEP operation maintenance Mirina Mulhak, Sridhar design engineering, Rahul student, Arun TNC manager now shifted to design. That's great to hear. Roshan project, Samson operation maintenance, Karthik project management, Saran Saka O&M, Sakti Priya student. Yeah, I guess like chats are flying, so I didn't probably read everybody's. Rajesh design engineer, Leona testing and commissioning, protection engineer, Chauhan working as electrical engineer in TCE, Uttam Kumar, great to hear. Execution engineer Kausik, Dr. K. Paki Lakshmi student. Yep. After finishing PhD, calling yourself as student, great to hear. New products, GE Vernova, thank you so much. Sony, probably like, is it your name or is it your laptop? All right, I guess like there are quite a lot of chats which I have missed, but like we will try to cover everything. Maybe one last question which I want to ask. Uh, if you have experience, just put how many years, that number, experience in years. If you're a student or if you're not having experience, put zero in chat. Like, say, example, if you have 3 years experience, put three in chat. If you have 5.5 years experience, just put 5.5 in chat. If you're a student or if you do not have any experience, just put zero in chat. So that defines, like, I mean, to say how I have to properly handle it. Okay, I'm not a PhD holder. All right, no worries, Pakilashmi. Absolutely fine. Satish shot 10, Arun 16 plus, Tejas V16, Uttam 2.5, Liana 12, Aman 5, Asikali 0, student obvious, Ajo 3 years, Kunjan 11, Kudos Maiti 3, Rian 4, Rahul 0, Tejas 10 years, Srihari 3 years, 1 year in design, Sachin 9 years, HP 7, Hasanka 8 years, Adol 17, Banupriya 0, Engineer Floris 0, Sampunu 0 experience, Omakom Samson 1, Saktipriya 0. I'm not sure like how to pronounce that name. Toka something 7 years. Subhas 15, Dinesh 0, Nikul 5, Mir Inam Ulkag 8, Syed 10, Balaji 8, 16 years, 5 years in project management, Karthik 6.5 years, Venkatesh, Isam Muhammad 0, Rajesh Kumar 15, 0 experience, but finally electrical students. That's great sample. 10 years Alabi Sivam, 4 years Vinod, 5 years. I guess like it's giving some some good experience. 4 years design MEP zero in power sectors in the HSC field, 6 months in project management, 25 years. I got like the variety of audience. I have promised, uh, like I mean, so say that as a last question. Otherwise, I would have asked one more question. Like I mean, so say, let me break my uh, promise and ask one last question. Which city and which country you are joining from? Which city and which country you are joining from? Which city? I know I'm breaking my promise. I have missed it anyway. Thank you so much. Sivam from Vadodara, Kiran from Ahmedabad, Visak, Colombo, Bengaluru, Bhubaneswar, Nigeria, Kerala, Vellore, Kuntur, United States, Nagpur, Tanzania, Mumbai, Algiers, Vadodara, Algeria, Morocco, Nepal, Morocco, Delhi, Hyderabad, Saudi, Jeddah, Saudi, Philippines, Jubail, KSA. I came to Jubail, Venkatesh, probably about 2, 3 months back. Coming Chennai, London, UK, Saudi Arabia, Riyadh, Surat, Saudi, Jammu, Vaisa, Kanchipuram, TN, Riyadh, Jugath, Lagos, Nigeria, Coimbatore. Thank you so much, Dinesh, joining from Coimbatore. Delhi, Kanku, Bhopal, Madhya Pradesh, London, UK, Kazakhstan, Coimbatore. Yep, I'm seeing like second student from Coimbatore. That's great to see. Arnachalam, Kuwait, Rajasthan. Surya Prakash, third student from Coimbatore. That's great to see. All right. Which means like, I mean, so see, we are enhancing our local presence. Yep, that's great. All right. Let's get into the topic straight away with one of the slides. Let me keep that it open as well so that like I'm probably picking up from somewhere. All right. So let me pick it up. One of the single line diagram, which is drawn in other simulation software. Of course, like I have marked with something here and there. Let's leave it and probably like try to do that. And like means to say we have an ETAP single line diagram for that as well. And we will try to develop the same in ETAP today. And like we will try to do like I mean to say as max as possible. And yes, I hope my screen is visible, right? Like if my visibles like some single line diagram and ETAP single line diagram, like if both the single line diagrams are visible, just put V in chat. I'm facing some challenges from my side, like I'm just reconfirming whether it is visible. All right, that's visible. Then here we go. So single line diagram is visible. Something which we have done in ETAP is also visible. Today's topic is mastering ETAP. Probably let's try to do the single line diagram. And like I mean, so say, let's try to evaluate as max as possible and understand and align ourselves so that like we kept everything. So whatever the marks which I have taken, like I will probably remove this and then here we go. Yes. Let me check ETAP is visible. Yes. Let me create a new project as well. So let me open a Word file too. All right. Now let me jump into my recording as well so that like means to see if anything Manoj has missed out, like that will be captured from my side. Yep. Yes. So we have an empty word file which we will fill it along the go. We have ETAP single line diagram which has been drawn from the single line diagram which is available in some other simulation software. So here what you are seeing, let's understand the system. Let's understand the system. The system has like 220 kV bus. There's 220 kV substation. From 220 kV substation, there is two numbers of 100 MVA transformers stepping down to 110 kV. The transformers are operating in parallel. There is a 12-kilometer overhead line, ACSR Panther conductor, single circuit transmission line is there, which is connecting to another 110 kV substation where there is a loads, which essentially mean there is 110 bar 33 kV, 110 bar 11 kV step down distribution transformers feeding a load. But like the load has been modeled as a lumped load with 17.29 megawatt. Of course, power factor is not given, which you need to make an assumption. From that substation, there is a double circuit ACSR links conductor to the substation where the substation is feeding the steel industry. So this has like main and transfer scheme of 110 kV and 110 kV. There is 35 slash 40 MVA 110 bar 33 kV transformer, which is there stepping down from 110 kV to 33 kV. 33 kV side neutral is grounded via 19 ohm resistor, which is limiting single line to ground fault current to 1000 amps. And 33 kV, you have like means to say one incomer with the four outgoing feeders. First one, 4 megawatt rolling mill main drive. Second one, 20 MVA transformer stepping down from 33 kV to 0.63 kV. That is feeding electric arc furnace, highly nonlinear, highly fluctuating load. And other one, 6 MVA transformer, 33 kV stepping down to 0.32 kV, Ladle refining furnace. And the fourth feeder is fifth harmonic filter bank. This may not be there at the stage of the beginning. You have to perform a harmonic analysis and then probably identify what's the rating of this filter. So, but at least like means to say, you have main drive. That name itself says it's a drive. So obviously there is a Powertronics variable frequency drive that injects a harmonics. Electric arc furnace, even a voltage source harmonics, which definitely injects a harmonics. Ladle refining furnace that also injects the harmonics. Then obviously when the point of interconnection, if the harmonics are not within the limit, you need to design a filter and the filter has been designed as well, which is presented here. And there is another 110 bar 11 kV 15 MVA transformer, 11 kV bus. There are many 11 bar 415 volt transformers, 1.25 MVA transformer 1, 1.25 MVA transformer 2, 3 MVA transformer 2, sorry, transformer 3 MVA first, 3 MVA second, 3 into 500 kVA transformer, and 11 bar 6.3 kV transformers stepping down from 11 kV to 6.9 kV, 315 kVA small transformer, 750 kilowatt oxygen plant direct online motor. There is another 500 kVA step down transformer and capacitor bank 5 MVA for power factor improvement. Since it is a steel industry, like I mean to say, there is a cogeneration as well. There is a 35 megawatt generator via 45 MVA step up transformer. A generator steps up to 110 kV and connect to the grid. If that's clear so far, just put CC in chat at least, even if you're not getting everything, but at least like a high level overview of the industry. Steel industry, which receives the power supply at 110 kV. So if you got something about this information about this industry, just put CC in chat. If you need any additional information, let me know your question in the chat. I will answer it. And then probably like we will start going to this Excel or probably that Word file and we will try to start fulfilling it. Thank you so much, Sony, for crystal clear. All right. When everything is clear, let me take a notes. It is steel industry, main loads are drive 4 megawatt, electric arc furnace EAF 20 MVA transformers, so approximately maybe 16 MVA load. Ladle refining furnace 6 MVA transformer, maybe 4.5 MVA load. These are all probably like means to say main loads which are connected at like means to say 33 kV. Right? So when we talk about it's 33 kV, 26 plus 4, it is like 4 megawatt here, maybe 30, 31.5 MV, etc. So this 33 kV is fed by 110 bar 33 kV 35 slash 40 MVA transformer. This is the load. So this is highly nonlinear load. There is a filter which has been proposed as well, right? That's the fifth order. That's probably like what SLD indicates, but like you have to perform harmonic analysis to uh, like I mean to say understand. Like it means to say if you look at like means to say next one 11 kV, there is 110 bar 11 kV 15 MVA transformer. From 15 MVA, like here you have like multiple loads, 2 into 1250 kVA transformer, 2 into 3000 kVA transformer, 3 into 500 kVA transformer, then 1 into 315 kVA transformer, and 1 into 500 kVA transformer. These are all like means to say 11 bar 0.433 kV like step down transformers. There is another transformer which is stepping down from 11 kV to 6.9 kV or 6.6 kV. That is a 6.3 MVA transformer. So let me check my memory is right or not. Like means to say 11 bar 415 volt. How many transformers which are here? Two numbers of 1250 kVA. That's right. Two numbers of 3 MVA, which is right. Three numbers of 500 kVA, which is right. 6.3 MVA, 11 that 11 bar 6.9 kV, that is right. 315 kVA, that is perfect. 500 kVA, which is perfect. What I have missed is a 750 kilowatt DOL motor, which I have missed it, and a capacitor bank of 5 MVR, like means to say, for power factor improvement is what I have missed it. So I have probably made a note of it. If you think like I have memorized this data, answer is no. This is the project which I have done 20 years back when I have started as a power system engineer. And like means to say, I have taken this as a reference at least in 200 of my sessions. And that's the real reason why like I still remember this. I have not mugged it up, but like I mean to say, since I have probably like used it again and again, and then as an example, like I mean to say, uh, so I am remembering things. So if you want to become an expert in power systems, it is quite easy. Learn something, start teaching. You will make mistakes. You will correct it over the period. Fail fast, fail better. You will become an expert shortly. And if that is making sense, just type MS in chat. Yeah, it's not technical, but if you want to grow quickly in power systems, the way which you have to grow is you have to learn and you have to teach to others. If you teach, you will grow fast. All right, I guess like that's making sense for many. Cool. And like 135 megawatt captive power plant, it's a steam turbine. So 110 kV is main and transfer bus. So which has three outgoing feeders, two incoming transmission lines. What are the outgoing feeders? One is this 33 bar, sorry, 110 bar 33 kV 35/40 MVA transformer. Other one is 110 bar 11 kV 15 MVA transformer. The third one is 35 megawatt CPP, which is having another 45 MVA 110 bar 11 kV transformer. It might be a step up transformer, right? And it has two incoming lines. Both are like 3 kilometers overhead lines. And this overhead line is coming from another substation where like about 17.29 megawatt load is connected. And other like means the line is about like 12 kilometer and like means to say two numbers of 100 MVA transformer. So this is an industry. So like means see, like if you talk about a power system, if you are talking about a power system, like if you're talking about a power system, you have generation G, you have a transmission like T, you have a distribution which is D, and if you want, you can add utilization U. So, do we have a generation in this SLD? Answer is yes, we have a generation. Do we have a transmission? Yes, we have a transmission at 10 kV. So, definitely it's a transmission. Whether we have a distribution, answer is yes, of course. Like we have step down and like we have all these distributions. Whether you have utilization, answer is yes, we are utilizing and converting into like means to say motor, we are converting into mechanical energy, electric arc furnace, we are converting into heat, motor drive, like we are running some motors again. So it's a typical example of a project which has a generation in it, which has a transmission in it, which has a distribution in it, which has a utilization also in it. Why this first example, like 20 years back, which I have done this project, but why I'm probably using the same example because this is the best example, which probably helps. Because if you talk about a power system studies, you need to perform load flow, you need to perform short circuit, you need to perform motor acceleration, you need to perform transient stability, you need to perform relay coordination, you need to perform an arc flash study, you need to perform harmonic analysis, you need to perform grid islanding and load setting, you have to perform an earthing. This is a simple project which has an application of all. You take this project, you need to perform a load flow analysis. Why do you need to perform a load flow analysis? To find out the capacitor bank rating. To check what's the generator terminal voltage which you have to check. Like you need to check like whether OLTC is needed or de-energized tap changes are enough. If OLTC is needed, what is the minimum tap and what is the maximum tap which we need to set? What's the power factor at the point of interconnection? Whether the equipment loadings are within the limit or not. What's the total losses in the system? What's the best possible configurations? If the grid fails, how the system operates? With the grid, like means how this generator is sharing real and reactive power and maintaining power factor at the point of interconnections. This all has to be captured in load flow analysis. I know I'm little fast, but like if I'm looking at load flow, in order to find out a voltage profile at all buses, to find out equipment loading in all branches, to find out losses in each branch and total losses, when I mean like both real and reactive power losses, to decide whether OLTC is needed or de-energized tap changer is enough. If it is OLTC, like means in order to identify the range of the OLTC, to find out the power factor corrections, capacitor banks or a reactive power compensation to maintain the power factor at the point of interconnection, to decide what's the generated terminal set point voltage which we need to use, whether it's 100% or 101% or 102% and why. What's the optimal configuration Without grid, like means to say n minus 1 contingency, like when the grid fails, like means to say how the system behaves and how the system operates, like how the generator to be scheduled so that, like means to say, that's optimal. So like you need to answer like n number of questions. These are all the questions which you can address only from load flow analysis. If you, like means say, what's the short circuit withstand capability which is needed for all equipments at 33 kV, 11 kV, 6.6 kV, and 415 volt? What is the braking capability, making capability, and the DC interrupting capabilities of all breakers? Right? Braking, making, DC interrupting capabilities of all breakers. And like means to say, to check like over voltage during short circuit. Yes, I meant over voltage. During single line to ground fault at 33 kV, what's the rise in voltage? During single line to ground fault at 11 kV, what's the rise in voltage in the healthy phase when there is a single line to ground fault? To identify all this, you need to probably do a short circuit. To check the 750 kilowatt motor is able to start or not in direct online, which you need to perform motor starting study. If there is a fault in 220 kV or 110 kV or 33 kV, whether the generator remains in synchronism with the grid or not, within how much time the fault has to be cleared so that this generator remains in synchronism with the grid. This are all something like which you need to look at. This is basically called critical clearing time. So you need to find out a critical clearing time that's to be done from a transient stability. And protection coordination, of course, isolate the fault as soon as possible is an objective. Whether I'm clearing the fault well within the critical clearing time, whether I'm isolating the fault within the short circuit capability of an equipments, whether I'm able to isolate the fault, whether I'm sensitive enough, is there any mal operations? You need to do relay coordination. If I am doing on load maintenance or a live maintenance, you call, if you're doing a live maintenance, like you need to ensure that, like means to say, personal safety, which essentially come from, like means to say, PPE, personal protective equipments, which you need to wear. So you need to perform an R flash study. Since you have like so many nonlinear loads, how do you design your filter? You need harmonic analysis. If for suddenly if the grid fails, or probably like if there is a fault here, probably this breaker and this breaker will open. Like how the system probably comes to the standalone mode and probably like feed the loads which is needed. And like means if the generator is not capable of feeding the loads, how this load setting to be done to maintain the voltage and frequency constant. And like when this generator AVR has to move from maybe MVR control mode or a power factor control mode to voltage control mode, and like when it has to move from droop mode to like isochronous mode, which is like means to say constant frequency mode, all these things has to come from grid islanding, and of course earthing, step touch potential, etc. So why this project? Answer is quite simple. This project is example it is taken. This project involves like all power system studies which is actually needed to identify and optimize this project. If so far so clear, just put CC in chat. So far so clear, just put CC in chat. Like means to say, what I am doing now in next 30 minutes, if you go through this course of the like I mean to say wake up call sessions, you will be able to do that probably 6 months down the line or 9 months down the line, what I'm doing in next 30 minutes. So I'm just putting ETAP wake up call itself. So let's get jump into this. So what I have done, I'm probably trying to put up this projects very quickly in a single line diagram format because I have this single line diagram. I have done sometimes back this in ETAP, and I have probably made a notes, and probably like let's check like how much time it takes for us to like I mean to say uh like do this project. Project standard, like means say the project is in India, so like means say it's IEC ANSI, so I need to put IEC standard. Frequency is 50 hertz. Unit system, I am following metric. So if you are starting any projects, this is an important standard frequency unit systems. This is important. So project standards is where you have to start with. I am putting like project informations. I am putting project title as like wake up call. Location I am putting like means to say Coimbatore. I am just putting like means to say 1 2 3 4 5 6 is a contract name. I am writing my own number, sorry, name as engineer name, and I'm putting my company as a company here. Remarks, wake up call, free masterclass. That's the remarks which I have given. And let's get started with the projects. So I have enabled the auto builder option. I am selecting the list of voltages which are possible. So what's the voltage available in this project? I know it is 220 kV, which is 110 kV, which is 33 kV, 11 kV, 6.6 kV, and 0.415, like all the voltages which I have picked up. 220 kV, 110 kV, 33 kV, 11 kV, 6.6 kV, 415 volt. These are all the voltages which are available in the project. I am probably like I mean to say done with first option, and then like means to say I'm just starting my first equipment. So first equipment is grid, which is at 220 kV, and like means to say I need to probably set this voltage to 220 kV. So project has like 220, 110, 33, 11, 6.6 and 415. It is 220 kV. Grid short circuit MVA is what I need to enter. Of course, it is 4890 MVA. I am giving 4890 MVA with X by R of 14. And let's go ahead with another informations like me say transformer. It is 100 MVA transformer stepping down to 110 kV. There is an overhead line of 12 km, 110 kV bus. There is a 17.28 megawatt lump load which is connected. There is another 3 km overhead line double circuit which is connected, and it is 110 kV like main bus. To an extent, I am done with my model of up to this industry. It is 220 bar 110 kV, 100 MVA transformer. I am checking the impedance, typical impedance I am giving, and probably validating the impedance. Here, the impedance is only 10%. I have given. Typical, it is giving like 12.5. So I'm changing it to 10. So there are two transformers in parallel. So I'm probably like means to say just copy and pasting this second transformer as well, which means now model here is done. So it is 12 km line, 12 km line. So I need to enter the transmission line parameters of that particular conductor. So if I have a conductor data, I can directly enter the RX values. If not, I can probably follow the configuration of what's the configuration which is available. Both the options works. So I'm trying maybe the second option. I have given the transmission line conductor parameters, transmission tower configurations. Automatically, the software has calculated the resistance, and probably it is a single circuit. 17.28 megawatt is what we have seen. So 17.28 megawatt, and like power factor, like I have assumed 0.96, the load which I have done. And probably like this is a double circuit line, it is a 3 kilometer line. So again, I have to probably select the conductor parameter, and like I need to put up a configuration of this conductor. The software has automatically calculated the like line parameters, and like if I need to probably do a double circuit, I am I am done with the double circuit line. And like probably like means to say up to this ETAP SLD, where it is probably drawn here, it is drawn in the horizontal format. If you want to rotate everything, you can probably like means to say rotate, like means to say minus 90 degree. So I guess like means to say whatever you have modeled, whatever things there, like means to say that will probably like means to say appear here. Only thing like this bus probably like means to say they kept it at like means horizontal, so which you can probably rotate it again, you will get it. So this load is leaking towards left, which you can model it. If you want, like means to say you can slightly extend it for beautification. And if you want, like means to say this bus data, like means to say transformer 1, transformer 2, all this data which you can probably like means to say it is bus 3 here. All right, like this is main bus bar, and like this line details also done. So like it's not really taking much of our time, and probably like if you want to display all the parameters of the transformers transmission lines, you can probably display whatever the informations which you want to display. So we have displayed the transmission line parameters, we have displayed the transformer parameters. So what are the parameters which you want, like you can probably like display it. And if you still want to move this towards right little, you are probably able to easily move it. And yes, if you want to move a little further, that alignment also, which you can pretty much do. Yes. And like I mean to say, whether you will be able to add like further, yes, you will be. So it is 110 bar 33 kV. Like I mean to say, you have pretty much like the transformer which you have added. And probably like means to say if you want to add a cable, you can add like means to say main bus bar. If you want to add, like you can add, like means to say further you can probably put up a like variable frequency drive or a main drive of like 4 megawatt. 33 kV definitely like means to say it is not the like means to say motor. It's a lump load, it is considered like means to say I'm just putting same thing, like means to say 4 megawatt, maybe 3 MVR, like variable frequency drive, which probably like we are done with. So this transformer rating is now available. This transformer rating is 35/40 MVA. Oil natural, air natural, oil natural, air forced. So and impedance is 10%. That information is also done. Grounding, it is star resistance grounded, limiting the current to 1000 amps. That is also done. So, like first feeder, lump load, which is done. Up to this, we are done. And probably like means to say here, like we have to put like electric arc furnace and ladle refining furnace. That's pretty much of the other loads. So here, like we need to add the size of the cables. 3 core 300 square mm cable for a 500 meter. 500 meter. 3 core 300 square mm cable. Like voltage rating is 33 kV. That's clear. So it is 3 core XLPE 300 square mm cable done. And like means to say here it is 3 runs, 3 core 400 square mm cable. It is 3 core 400 square mm cable. 33 kV is the voltage. 3 core 400 square mm cable. 3 runs, 100 meters. And it is 2 run 3 core 300, single run 3 core 300. So like which means like I can probably display the cable type, length, all these parameters, right? I guess like cable import another parameter which I have not really displayed is type, sorry, size. Yeah. So lump load which I have put like it is main drive. Sorry, main drive. So I need to probably like means to say copy this with the 2 runs. I have to copy this with the 2 runs, and it is 33 bar 6.6 0.66 20 MVA transformer, 0.6 20 MVA transformer, 0.63 20 MVA transformer. Impedance, I'm going for a typical, and like means to say, I'm just of course connecting a bus to that. We are done with, we have to put of course a lump load for it. I have connected a lump load as well. I'm connecting about like 16 percentage, 80 percentage of this lump load for this. I'm done. So it is electric arc furnace. If I want to rename this, I can probably rename it as electric arc furnace, probably in the load as well as the bus. Similar fashion, I can probably like means to say copy this and paste it. Like it is only single run. It is 6 MVA, and it is maybe I can probably rewrite it as like 4.8 MVA or something. So whatever the loads which is drawn here, except a harmonic filter, I have modeled this. Then it is quite simple and straightforward. I have to come down to 110 kV, another transformer which is stepping down from 110 kV to 11 kV. So, and here the voltage is not 33 kV. Here the voltage is 11 kV. That's it. Like it's 11 kV. It is 15 MVA transformer, and impedance typical, grounding limiting single line to ground fault current to 600 amps, right? 10.5 ohms, and we are done with. And if you want to display the symbol, you can display the symbol. So what actually we are trying to do this, we are trying to build the single line diagram. We are trying to build the single line diagram. Why we are building the single line diagram is an important question. So like how much time it took for us? It hardly took 10 minutes for us. And probably like if we go in the same speed, like means the remaining things, we will be able to finish it in another 20 minutes. I'm not really going to do that. But like means see, typically you will be able to do that. So if you want, like we can probably add like one more uh, device as well, which is generator. So here let's probably pick it up again 11 kV and force this 11 kV, and we are done. So how much is the transformer rating? Transformer rating is 45 MVA. Typical impedance I am giving. Grounding star grounded delta. And like what's the capacity of generator? 35 megawatt. And I'm just running the load flow. Yes, I'm running the load flow and I'm getting some results. Here it is some power is flowing, voltage is 100%, like here voltage is 98 percentage, here voltage is 97.39 percentage, here the voltage is 97.26. Here I have not modeled any load, so like power is not flowing. So here it is 92.85, 92.84. Generator is there, but it is not generating power. So lump load, like I mean to say, everywhere like power is to an extent power is flowing. Yep. If I want to display the units, I can display the units. So far, what I have done, I have not really behaved as a power system engineer. I have behaved as a tool operator. What I have done, I have done a task of a tool operator. What I have done, I have just probably like means to say copy pasted or just modeled what is there in this. I have never asked a question why it is, and I have never asked a question like means to say how it is to be modeled. I have never asked a question like means to say what is to be done, etc., etc. So, all right, I'm done. Thank you all. Thank you so much. Have a great weekend.